Hello students, welcome to the solid state defects, part 2, impurity and non-stoichiometric defects. Let us start. Impurity defects. In solids, in ionic solids especially, some cations are replaced from their regular sites by some other cations with higher charge, and this creates impurity defects. These defects in ionic crystals basically arise due to the presence of some impurity ions at the lattice sites in place of host ions or at the vacant interstitial sites. Let us understand it by this video.
Impurity defects. So far, we have discussed point defects where there are no foreign atoms. Foreign atoms can occupy interstitial sites or lattice sites in a crystal. Defects in the ionic solids may be introduced by adding impurity ions. If the impurity ions are in a different valence state from that of the host ions, vacancies are created.
Let us see the example. Introduction of a cation vacancy in AgCl by substitution of Ag positive by Cd2 positive, and introduction of a cation vacancy in sodium chloride by substitution of Na positive by Sr2 positive. If molten sodium chloride containing a little amount of strontium chloride is allowed to crystallize, some of the sites of sodium ions are occupied by strontium ions. For each strontium ion introduced, 2 sodium ions are removed to maintain electrical neutrality. One of these lattice sites is occupied by strontium ion, Sr2 positive ion, and the other remains vacant. This is shown in this picture on right hand side. Therefore, these vacancies result in increased electrical conductivity of the solid. Similar defect and behavior is observed when cadmium chloride is added to AgCl as shown in the picture on left hand side. Non-stoichiometric defects. Here in this type of defects, the ratio of combining elements in the compound is different from that required by their stoichiometric formulae. The defects which disturb the stoichiometry of the compound are called non-stoichiometric compounds. These defects are either due to the presence of excess metal ions or excess non-metal ions. Non-stoichiometric compounds are of two types. These type of defects are of basically two types in this non-stoichiometric compounds. First is metal excess defect, second is metal deficiency defect. Let us see them one by one. Metal excess defect. It is due to anions. Negative ions may be missing from the lattice sites, leaving holes in which electrons remain trapped to maintain the electrical neutrality. The F centers are created at these sites. F center are the anionic sites occupied by unpaired electrons, imparting color to crystal lattice. Let us understand it by this video.
An ionic solid, an anion may be missing from its lattice site, leaving a hole which is occupied by an electron to maintain the electrical neutrality. The anionic site occupied by an unpaired electron is called F centers, where F stands for Farbencenter, which is a German word for color center. F centers are responsible for the color of the compound. This kind of defect is shown as alkali halides, such as sodium chloride and potassium chloride.
The F centers are basically responsible for the color in these solids. Excess of sodium makes the crystal appear yellow. Excess of potassium in potassium chloride makes the crystal appear violet or lilac. excess of lithium in lithium chloride makes the crystal appear pink. Let us see excess cations occupying interstitial sites. When some extra positive ions occupy interstitial sites to maintain the electrical neutrality, some extra electrons occupy some other interstitial sites, resulting in defect. Let us understand it by this video.
This type of defect, metal excess, is caused by an extra cation occupying the interstitial site. To maintain electrical neutrality, an extra electron is also present in some other interstitial site. This defect is found in crystals having Frankel defects.
Let us see the common example, which is zinc oxide. Zinc oxide is white in color at room temperature. On heating, it loses oxygen reversibly at high temperature and turns yellow in color. Zinc oxide is heated in zinc vapor, and on heating, zinc 2 positive ions occupy the interstitial site along with the 2 electrons, and it turns yellow in color. Metal deficiency defect. Here, few metal cations are missing crystal lattice, and it causes some vacant point or holes, creating metal deficiency defects. In some cases, the positive ions may be missing from their lattice sites, and the extra negative charge may be balanced by some nearby metal ion acquiring 2 positive charges instead of 1. Let us understand by this video.
Metal deficiency defect. This kind of metal deficiency defect is created when a metal ion goes missing from its original lattice site. To maintain the charge neutrality, same metal ion having higher positive charge is added to occupy the vacancies created in the crystal. As this metal ion has higher positive charge, it will occupy only some of the sites to balance the overall charge, and other sites will be left vacant.
So as you have seen, this was this part 2, and I hope you have learnt it. Please revise it by watching the videos and learn it thoroughly. Thank you.